All right, class, we made it to one of the final lessons of the module. This is the 5.1F lesson, Operations with Scientific Notation. And today we're going to practice a lot of multiplying numbers that are in scientific notation together. Obviously, we can also divide. And let's just get right to it. Okay, so it says, number 1, does 5 times 3 in a group times 2 times 8 equal 5 times 2 in a group times 3 times 8? If so, explain your reasoning and state which property is being used. So the key here, class, that we should realize is every single operation in this expression is multiplication, right? And for this reason, we are then allowed to switch the order because of the commutative property of multiplication, right? We can pick and choose which numbers we would like to multiply. Honestly, I think instead of 5 times 3, I would do 5 times 2 instead. And then 3 times 8, which we know is 24. And we know that 5 times 2 is 10. So this makes it easier for us to calculate, right? This process of kind of deciding which two numbers to multiply first is something that we're going to do when we multiply two numbers that are in scientific notation, right? So take a look at number 2. Now, again, this only is allowed if every single operation is the same. If this was an addition sign, well, at first it wouldn't even be in scientific notation anymore, but you wouldn't be able to kind of pick and choose which two numbers you want to multiply, right? So in order to do something like number 2, the first thing I want you to take a look at is 10 cubed times 10 to the 6. I'm going to go ahead and calculate that, right? We know that 10 cubed times 10 to the 6 is 10 to the 9. Okay. Then, so we've already gotten the placeholders correct. And now we just have to figure out what 1.9 times 2.4 is. So I don't expect you to do that in your head. Let's just calculate that using a calculator. 1.9 times 2.4 is 4.56. And our answer needs to be in scientific notation. And right now, it currently is. And I'm done. That was easy, right? Again, step 1 was to figure out the placeholders, 10 cubed times 10 to the 6. And then step 2 was to figure out 1.9 times 2.4. Okay, let's try another multiplication one before we dive into the division. Let's try number 4. So step 1, identify your placeholders. 10 to the 5th with 10 to the negative 3 is going to be 10 squared, the sum of 5 and negative 3. I know that 7 times 3.5 is my next step. You can do that in your head, but honestly, if we're allowing calculators, you might not want to risk the mental calculation. And 7 times 3.5 is 24.5. Now, I would box this answer if this was in scientific notation. What do we notice about this right now, class? Right? We're noticing, wait a minute, the decimal is not where it needs to be. And in order to place it, I need to move it back one placeholder, which is a -1 placeholder movement, right? I'm moving back one placeholder, one spot. And the number is like, hey, I was a 24.5. You made me a 2.45. You took away one placeholder. And you're like, okay, so if I take away one placeholder, don't worry, I'll give you one back. And that allows the number to still have the equivalent value, right? So then now the final answer, 2.45 times 10 to the third. That's our final. This process in sky blue is very, very important, right? You take away one placeholder, you have to give it back to the exponent of your base 10. Okay. Yeah, so let's try number 6. Let's try number 6. So 6, first of all, this number 52 is not even in scientific notation. So if I try to pair 10 negative 3 with anything, it will just be 10 negative 3, right? There's nothing to combine with 10 negative 3. We do know that in scientific notation, you always have, a number times 10 of something. So the next thing I'm going to do is just simply calculate 3.1 times 52. 3.1 times 52 is going to give me 161.2. And you can see that this number needs some editing, right? This number is not in scientific notation. So again, all we need to do is we need to move 2 placeholders. You take away 2 placeholders, you make the 161 1.612. And if you take away 2 placeholders, you have to give 2 placeholders back, right? -2 and +2 will cancel. Your final answer is going to be 1.612. You can't ignore any of these digits. These are very, very important. You can't round it. You shouldn't round it unless it says to do that. But 1.612 times 10 to the -1. This is your answer. All right. I feel like that's decently, I hope that's easily understandable. The commutative property of multiplication allows us to switch the order in which we multiply things. And it also kind of indirectly allows us to switch the order in which we divide, right? So this next section, when we divide 2 numbers that are in scientific notation, I want you to think of it kind of like the way we did multiplication, right? So my attention immediately should go to here, 10 to the 5th divided by 10 squared. And so I would say divide the base 10s first, right? So figure out what that ratio is. And in this case, 10 to the 5th divided by 10 squared is 10 cubed, right? And then next is you divide 7.2 with 3.6. And I don't even need a calculator for that. I know that 7.2 divided by 3.6 is just 2, right? So it's 2.0 times 10 to the 3rd. And that's my final answer, right? That's going to be, this is already in scientific notation. So I kind of lucked out on that, right? Here, number 5, you can see that I have 10 cubed divided by 10 to the 7. And if you can't see it, let's just remind ourselves. Like, I know typically we could say 1 over 10 to the 4th. But in scientific notation, we do not want a fraction for this ratio. We're okay with negative exponents. Usually negative exponents are not allowed. You're not supposed to have a final answer with a negative exponent. But in scientific notation, negative exponents are allowed. So I actually want everyone to calculate this 3 minus 7 and just leave it as a negative, right? This is going to be 10 to the -4, okay? So 10 to the -4 is what we know for that first part. And again, you don't want to write 1 over 10 to the 4th because that's not how you write something in scientific notation. The next thing I want to calculate is that ratio. And I'm going to use a calculator for that, right? So 2.3958 divided by 1.98 gives me 1.21. And I'm happy with that because the 1.21 has the decimal at the right spot. And I'm done. Okay. 7, interesting. Again, you could really write 30 times 10 to the 0 if you really want, because you know that 10 to the 0 is just 1. So now I'm going to calculate the ratio of 10 to the 0 divided by 10 to the 5th. And that's going to give me 10 to the negative 5. That's my first calculation, right? 0 minus 5 is negative 5. Leave your answer. Leave your exponent as a negative, right? You want to leave it as a negative because that's what scientific notation is. Okay, the next thing we do is 30 divided by 1.2. And now you get 25 for that. Now it goes back to this process. Is that the final answer, class? All right, we're noticing the 25 is not going to be the final answer. So we're going to have to move the decimal place one spot. You take away one placeholder. If you take away, write the -1, give the +1 to the placeholder for the 10, and then you have your final answer as 2.5 times 10 to the negative 4. Simple. I hope you guys enjoyed that. And let's go on to the next page. Right. So the next page says to use scientific notation and exponent rules to solve each word problem. Write your answer in a complete sentence using standard notation. Okay, so let's do one problem. I think this is a good time for you to just practice. These are word problems that involve scientific notation. For me, class, what you have to focus on is, am I supposed to multiply the two numbers or am I supposed to divide the two numbers? Obviously, they don't tell you because then that'd be easy. You're just going to have to figure that out. So let's read number 8. Number 8 says, the human body uses red blood cells to deliver oxygen to the organs. An average adult has about 2 times 10 to the 13 red blood cells. Each cell is 2 times 10 to the negative 5 meters long. Really, really small, right? Each cell is really, really small, but you have 2 times 10 to the 13 red blood cells. If all of the body's red blood cells were lined up, how many meters would it be? Okay, so I hope you realize that this is a perfect example of multiplication, right? I'm just going to write multiply, and you just go 2 times 10 to the 13, and then you multiply that with the length of each individual cell, which is really, really small, and you figure it out. Again, the first thing we have to calculate is the power of 10, right? 10 13 with 10 negative 5 is going to be 10 to the 8. Then the second thing is simple calculation of 2 times 2, which is 4. You say 4 times 10 to the 8th. Now that does, you can see how I was able to quickly multiply, but it does say that they want the answer in standard notation, right? This is scientific notation, but they want the final answer in standard, right? So the standard notation is all the blood cells would be, let's do 4, and then let's do 0, 0, 400 million meters long, right? And that gives us the 8. You could see that 4 times 10 to the 8th really means that I have 8 zeros. Okay, let's try number 9. Number 9 says the speed of light is 3 times 10 to the 8 meters per second. If the sun is 1.5 times 10 to the 11 meters from the Earth, how many seconds does it take light to reach the Earth? Okay, so this is back to the age-old ratio that speed is equal to your distance divided by your time. Right, miles per hour, right? Now, in this case, they actually give us the speed of light, which is 3 times 10 to the 8th. They give us a speed. They also tell us the distance the sun is from the Earth. They tell us the distance, and they don't tell us the time, right? So this is a perfect example of you have to understand that speed is always equal to your distance over time. And in this case, your speed is going to be 3 times 10 to the 8th meters per second. The distance is going to be 1.5 times 10 to the 11 meters. And we don't know what time is, so let's just call time x. All right, so if I set it up as it's seen now, you would literally do 3 times 10 to the 8th is equal to 1.5 times 10 to the 11 over x. Right? Now, you'll have more practice with this in, let's say, physics or another class in the future, maybe in high school. But one process that we can do is we can literally multiply both sides by x, and you would get x times here, and then you would get x right there, right? When you multiply both sides by x, you cancel the x's, and then you end up getting 3 times 10 to the 8 times x is equal to 1.5 times 10 to the 11. Okay, so our goal is to isolate x. The x is on the left side, so I'm going to have to divide both sides by 3 times 10 to the 8th. Right? And then x is going to equal 1.5 times 10 to the 11 divided by 3 times 10 to the 8th. That was a huge process, but just remember I multiplied both sides by x, and then I divided both sides by 3 times 10 to the 8th. Okay. This is going to give us 10 to the 3rd times 1.5 divided by 3, which is actually 1/2, which is actually 0.5. Now we run into another issue because now this is no longer in scientific notation. You're going to move one placeholder to the right, which is +1, and then you take away one placeholder. Your final answer is 5 times 10 squared seconds, which essentially is 500 seconds. Okay, this word problem was a little bit tricky. We had to know that the speed was equal to your distance over your time. Your rate is equal to d over t. And then you figure out, you kind of have to work your way to isolate x. And scientific notation indeed made our calculation easier. Okay, let's take a break right now. And when we come back, we're going to practice adding things that are in scientific notation.